We're all aware of the dynamic changes taking place in the electronics industry with devices such as iPhones, satellite radios, digital set-top boxes, high-definition TVs, and the latest GPS system. Behind the scenes, high-speed serial standards like PCI Express 2.0 and USB 3.0 are opening up a new world of computing for gaming and entertainment, as well as many commercial and business applications. In this segment, we'll be learning more about the bright future of DisplayPort and how with speed comes a range of design, test, and certification challenges. I'm Diana Jordan. We're at Tektronix, where we're talking with the experts and seeing a hands-on demonstration of DisplayPort compliance testing. Chris Loberg, who heads the company's design and manufacturing segment, talks to us about DisplayPort trends and opportunities.
DisplayPort is an important technology, and I think there's concerns and opportunities depending on how you look at it. From an opportunities perspective, I think that PC companies that are designing personal computers and wanting to move into the entertainment environment for gaming or video display, DisplayPort brings a lot of opportunities for them in terms of improved performance on the PC. From an engineering perspective, some of the concerns are related to it is a complex technology, and to adapt that technology into their environment is going to require engineers to understand a lot more about the testing requirements and be familiar with how to perform those tests. I liken it to PCI Express in terms of its system architecture, the signaling approach they take. Some of the test and measurement challenges associated with that are it's a complex signal. There's an embedded clock involved. There's multiple lanes of differential signaling going on. And for an engineer to characterize the DisplayPort system for compliance requires an understanding of a number of different compliance tests. In fact, I believe there's about 17 different tests required to characterize each lane of traffic for a DisplayPort signal. One of the things that I would emphasize there is each of these 17 tests falls into one of three categories. There's a sync test, there's a source test, and then there's a cable testing. And each of them have their own unique characteristics. For example, on a sync test, what they're trying to do is validate the performance of the receiver being the monitor of the system that's receiving the signal from the transmitter. And there's a number of unique requirements associated with that. Same thing goes for cable testing and for source testing as well. So each of them have their own unique challenges, and it's important for an engineer to understand the tests that are required and how to perform those tests. A DisplayPort spec is built around a standards organization called VESA, V-E-S-A. And VESA has been put in place to house the test spec, keep it current and updated for industry members, and then host authorized testing for compliance purposes. And all this is being done to ensure open interoperability so that when companies introduce DisplayPort capability, they know that for instance, their laptops and their monitors will coincide with one another, and there will be good interop. So how they run their program is VESA will post a test spec that's available for download on their website. On the website, you'll find a test spec and also a listing of authorized compliance test centers. And these test centers have been put in place for designers when they feel they have a compliance design to bring it into the test center and seek approval. With approval comes the ability to say, I have a DisplayPort compliant device, and then they can go to market with it. Tektronix is involved in a number of serial standards, and our goal with these standards for our customers, the engineers, is to make the testing process go easier and smoother. So what we've done first off is identify the instruments needed to perform the proper tests. And so there are benchmarks that are put in place in the DisplayPort test spec for performance from an instrument perspective. We want to make sure our instruments meet those performance benchmarks. As a result, then, Tektronix posts a set of recommended test equipment on our website for DisplayPort engineers to understand which test equipment is needed to perform the tests. So that's the beginning point. And then we take it a step further and we put out a document called an MOI, a method of implementation. And in this document, we basically take a step-by-step approach for seeking compliance using our equipment for each section of that test spec. For instance, we'll walk through 17 different tests on the source testing section, and if an engineer follows that MOI document, they will be led through a series of steps to complete all 17 tests. On top of that, we're also adding software into our instruments to enable the automation of some of these tests to occur easier and add additional reporting capability so that engineers can share with VISA and with their engineering management the output of the test results. Underpinning it all is the standard itself. The standard is very wisely put together, modeled behind like the PCI Express standard, which enables a scalability capability. And scalable means we can increase the data rate, we can improve the performance over time. So I see this technology just at the infancy stage now. Over time I see it growing in greater and greater performance. And so that's going to play out in a number of different markets. Video, gaming, commercial industries. So I think this technology's got a huge future ahead of it.
Now, Tektronix Technical Marketing Manager Randy White will demonstrate how simple it is to create DisplayPort test patterns and perform compliance testing.
This is a DisplayPort receiver test demo. It uses an 8 GHz real-time scope, an arbitrary waveform generator, and 2 DisplayPort test fixtures. One of the cool things about this setup is it uses a single instrument to generate the DisplayPort test patterns. I think that's a really innovative approach to generating DisplayPort test patterns for receiver testing. This demo is a 3-part process. First, we're going to generate the patterns using the AWG. Second, we're going to measure or calibrate the signals using a real-time oscilloscope. Third, we're going to run the test. I'll start by connecting the AWG to the scope with 2 fixtures. The software used to create the DisplayPort test patterns is called Serial Express. From the pull-down list, a variety of patterns are available, including the PRBS7 compliance test pattern for DisplayPort. It's compiled, it's then loaded into the AWG memory automatically, and is active at the output, Now that the pattern has been created, I will validate that the amplitude and jitter values meet the test requirements. Using the DPOJet software on my 8 GHz scope, I can see the values are within 5% of the required values. Also noted the jitter tone is at 20 MHz. With the pattern calibrated, I'll connect the test fixture to the sync device. Before starting the jitter tolerance test, the receiver needs to adjust its PLL and equalization settings. This is done through link training. In the same manner as I've done for the PRBS7 pattern, I previously generated link training patterns, a clock pattern, and a symbol lock pattern. In the waveform sequence list, there is a PRBS7 pattern which has a single bit error. The sequence has been programmed so that this pattern repeats 5 times. After inserting the 5-bit errors, I use a vendor-specific tool to read the error count, and it shows 5 errors. With the test patterns created and the error counter verified, I then run the 20 MHz pattern for the required time, and then count the number of errors. If this number is less than the limit, then the test passes. This demonstration showed how simple and easy it was to generate test patterns for receiver testing, specifically DisplayPort.
Tektronix has long been a leader in developing test solutions for emerging technologies. The company is always adding to its portfolio of solutions for high-speed serial standards as they emerge and evolve. So be sure to visit the Tektronix website at www.tek.com for more information.